Hey everyone, welcome back to another session of our SD-WAN training, Cisco SD-WAN training. Hope you all are doing good. This is Abhijit again, your instructor for this training, and I hope you all are doing good. Let's get started with this session. In this session, we will be talking about what is SD-WAN in terms of SDN based networking and what all are the components of Cisco's SD-WAN solution and the architecture of it. So let's dive into it. Now, this is kind of one of the important sessions that we're going to have for this training. So you need to understand it. So if required, you can watch the video once or twice or thrice, as long as you form a solid understanding on the topics which we are going to cover in this video. It will be quite helpful for you guys. So let's dive into it. And as we discussed about the introduction to SDN in the previous sessions, we are going to talk about what is SD-WAN. And post that, we will be talking about the components and architecture of SD-WAN, rather Cisco's SD-WAN. These two are going to be majority of the sections that we will be covering in this section of video. So when we speak about SD-WAN, as we already have discussed, that traditional WAN was designed to route traffic from remote sites to the company's data centers using private MPLS circuits, right? You can have scenarios where you have an ISP network, right? And that ISP network can allow you to have iNet connectivity, which is commodity internet circuits, to have public internet or private internet connectivity, or it can also be 3G or LTE services or even 5G services nowadays, right? That actually connects various remote branches of your organizations. So you might have a center that is situated in London. You might have another center that is situated in Dubai. And let's say there is another location which is in Singapore, and maybe another location which is in Delhi. And all of these devices or all of these fabrics needs to communicate with each other. So your employees who are sitting in London office wants to communicate with Singapore, then they want to communicate with Dubai, they also want to communicate with Delhi, and so on. Every other branch wants to communicate with every other branch that's available there. So in order to make this communication successful, you probably would be using ISP services, right? Some of you or some branches would be connected to iNet, which is commodity internet circuits. Some branches would be connected to iNet and MPLS both. Some branches would be connected to iNet, MPLS, and 3G. Some might be connected to a combination of 3G and MPLS. So it can be any combination that should allow communication from one side to other side very much. And this is exactly what we call a traditional WAN, right? So we can say that the business trends nowadays now have moved their applications out of the data centers. Earlier, it could be in a way that you will have on-premises data centers a lot, but with the game of virtualization, with the game of cloud, for example, if Singapore used to be your headquarter, and there would be a lot of server farms, right? And it can be your web server, it can be your mail server, and there can be chunk of servers hosted. So everyone in these sites would want to resources that are hosted into your headquarter. But now these applications are moving far away to cloud. Right? And the cloud connectivity enables you, right, to have all of your web servers, to all of your application servers, or any other server, database servers, mail server, whatever, to be hosted onto the cloud, right? And then the ISP is going to have the connectivity with the cloud, and this cloud can be anything. It can be the Google's cloud platform, it can be the Amazon's AWS, or it can be Microsoft Azure, right? Any of these cloud applications or cloud providers can host the applications and provide you the reachability and accessibility to these particular applications, which is basically called as traditional WAN. So in that case, since we are moving the users traffic from branches to the enterprise data centers and then out of the cloud or the internet, so in order to use traditional WAN, it's kind of becoming inefficient, it's kind of becoming expensive and unscalable or not so scalable. And the rapid digital transformation also of the enterprises create new requirements for security, for cloud and internet connectivity, for WAN management, for applications performance, right? All these factors comes into picture, and that's exactly where SD-WAN is going to help you instead of using traditional WAN. So with Cisco's SD-WAN, which is basically an overlay architecture that provides you the ability to manage your entire WAN infrastructure from a centralized point of touch according to the principles which are defined into software-defined networking, right? It is designed to meet the needs of modern enterprise applications and the rapidly growing security requirements, right? So be it basically when you speak about the common benefits that it provides you, speak about the benefits of SD-WAN. You can also consider them as features of SD-WAN. So number one thing is connectivity at any location, right? What does that mean? Means that you do not really need to push or deploy your team, your technical team at a specific site. Any technical member of your organization can just connect your WAN devices or WAN facing devices to the internet, and the device will take care of becoming part of the existing fabric, right? So it provides you the improvements over the traditional WAN of earlier, that if you have a new device that needs to be part of the fabric, then the device, let's say, which is kind of a new site, the London site is coming up new, then this WAN edge device will have to be configured in a way manually that it needs to create overlay tunnels with the headquarter. It also needs to create connectivity with the other side so that the communication can happen. It also needs to be configured in a way that it can talk to public internet and to the cloud appliances. So all the configuration needs to be deployed onto these particular fabric, right? So the device's manual configuration will be too much. And this is just about a single device. What if you have multiple devices that needs to be used, right? On all of those devices, the configurations must have been done manually in order to ensure that the connectivity from the newly coming up WAN edge device is provided, so that it connects to all the other branches that are available in the existing fabric. That is quite a task that you need to do. Since the connectivity at any location is provided by the SD-WAN fabric, you no longer need to sit onto that particular device physically and configure that device with every parameter that is required for it to be onboarded. You just need to provide connectivity of your WAN edges to the internet, and it will take care of rest of the things. All the necessary configurations in order to be connected with the data center side or the headquarters side or the other branches, or even ensuring the public internet connectivity, even ensuring the cloud connectivity, everything is automatically deployed with one of its technology called ZTP, which we understand as zero touch provisioning. So that's one of the major feature that SD-WAN solution provides you. Apart from that, it is also transport independent. Right? So when we say transport independent, it means that you are not required to only rely on to premium transports like MPLS for ensuring security of your communication. So it's not like all the sites only needs to be connected to MPLS underlay transport so that it can take the benefits of premium transports like MPLS. You can assure now the same level of security, the same level of quality. If the underlay is performing well, then your communication over public internet will also work in the most secure way possible, right? And it will also guarantee that all the traffic that's flowing between the branches using the public internet or commodity internet circuits will also flow the same way that it would using the premium circuits like MPLS. So you can use any type of transport in order to create your SD-WAN infrastructure. After that, the third thing that it provides you is the underlay abstraction. Right? So abstracting the underlying WAN infrastructure away from the services and applications that runs over the network is provided into the SD-WAN fabric, such as routing of internal networks between the branches, segmentation of network, right? Analytics and infrastructure as a service, multi-tenancy. All these services are provided using the overlay infrastructure. So underlay is quite abstracted, right? By using which you have the ability to keep your overlay and underlay information flowing from one point to the other point separated. Earlier, your important information in the traditional WAN would flow in the underlay itself, right? But now this is kind of centralized. So we have various type of controllers which takes care of transporting the important information or the SD-WAN related information in the overlay, and underlays just being kept for providing the connectivity between the physical connectivity between the branches. Once the physical connectivity comes up, then the overlay connectivity just takes care of the rest for forwarding any or for propagating any type of information in the entire SD-WAN fabric. Then after that, you also have the end-to-end security. Which is being provided, right? So providing end-to-end security from the remote sites to internet, to cloud, to software service appliance applications, or to even branch-to-branch connectivity is by default ensured by using overlay architecture. Post that, you also have single pane of glass, to which we also call as SPOG, which means that you can do the management of your fabric, you can do the analytics of the fabric, you can do the configuration of the fabric, you can do the policy provisioning of the fabric. All of these things can be done from a centralized point of touch. You do not need to jump onto every single device one by one in order to ensure that the communication happens properly, the configuration gets pushed, right? You do not need to sit on every single device one by one. From a centralized management GUI, you can manage the entire fabric from one place. So it's quite centralized. You can say, according to the concepts that we discussed yesterday, where management plane, control plane, and data plane are kept onto every device in the traditional way, but in the SDN way, the management plane, control plane are centralized, and data plane is something that is kept local onto the managed devices. So with the help of that, you achieve single pane of glass. And post that, you have various ways to interact with the controllers because you have REST API compatibility. So you can also achieve something sort of automation in order to push configurations or manage your entire WAN infrastructure with the help of REST API programmability. So that's something that you achieve by using or by implementing SD-WAN fabric into your network.